coming to another term. That is here is dimensional modeling. Dimensional modeling. It represents data into the cube operation, making more suitable logical data representation with OLAP data management. So basically dimensional modeling, that means we want to model our data into different dimensions. So dimensional modeling, it will represent the data with a cube operation. So this cube operation, it will make it more suitable logical data representation with the OLAP data management. In dimensional modeling, the transaction record, they are divided into either the facts, which are frequently numerical transaction data. Facts, like we have seen the numerical data that 360 bread pieces have been sold. So that is a form of fact. So in dimensional modeling, the transaction record, it can be divided into facts. Fact is what? The numerical transaction data. The numerical data. Or dimension, which are the reference information that gives context to the fact. Now dimension is what? Dimension is giving context to our fact. Like this 350 that we are talking about, what is it? So the one dimension of it is item, that it is a form of item. Another dimension for it is that 350 value. When is it coming? The time dimension. So it is in quarter 1, 350 breads were sold. So that these are the dimensions that we talk about here. Now for example, a sales transaction, it can be damaged into facts. It can be divided into facts like the number of products ordered and the price paid for the products, and into dimension like the order date, like the username, the product number, or we can say the order shipped to or the bill to location, and the salesman responsible for receiving that order. These are the different dimensions which provide context to the fact. If we are talking about the sales transaction, it can be divided into facts. What all facts can be there? The number of products ordered. That if we are talking about the sales transaction, how many products were ordered? Let us say 500 products were ordered. And the price paid for those products, if 500 products were ordered, suppose 1 lakh is the price paid for the products. These are the facts that we are storing. And dimension. Dimension, it will refer to the fact. It will provide reference to the fact. So that this particular order, what was the order date for it? When was this order placed? Then the username. Then we can have the product number, that suppose we are talking about any particular product, what is the number for that product? It can be the order shipped to and the bill to location. Then another dimension can be who is the salesman responsible for receiving that order. So in dimensional modeling, we represent all this data. Our record, we divide it into the facts and dimension, 2 parts. Now, what is the purpose of dimensional modeling? First, to produce the database architecture which is easy for the end clients to understand and to write the queries. Why we are doing this dimensional modeling? Why we are modeling our data into different dimensions? So that a particular architecture is produced which can be used by the end clients. At the end, there are the clients who are going to use this data. So they should be able to understand the data properly so that they can make the queries. Suppose the example we have taken, there is a person, there is a manager of the company. He wants to get to know that the product, what is the product being purchased at this particular point of time. So if we have designed we have done a dimensional modeling for our data, he can easily raise the query, and using this query, our operation will be performed easily using the dimensional modeling. So he can retrieve the answer to his query easily. So it will make our end clients to understand and write queries easily using that dimensional modeling. Secondly, to maximize the efficiency of the queries. It achieves these goals by minimizing the number of tables and the relationships between them. So basically our goal here is to maximize the efficiency of the queries. that whatever queries are being made, they should be efficient. So we need to maximize the efficiency of the queries. So what do? We try to reduce the number of tables. If there are number of tables, so the person who is using those tables, he has to analyze all the tables to retrieve answer to his query. But using dimensional modeling, what do? We make a proper cubical data in which we will store all the information. So it makes them easy to analyze the data. So basically, dimensional modeling, it represents the data with the cube operation, making it suitable for the logical data representation along with the OLAP data management, online analytical processing data management. So that is what is dimensional modeling. Now let us talk about the elements of dimensional modeling. The very important element of dimensional modeling, it is the fact, the dimension and the measure. Talking about the first one, which is a fact. Fact is a collection of associated data items consisting of measures and context data. It typically represents the business item or the business transaction. So if we understand for an example fact means what we are measuring. Collection of all those associated data items. Suppose for a ball we are considering, so the fact that we can consider for a ball is its size, its color, its shape and those things. So fact basically it is a collection of associated data item and it will consist of a measure. Measure means it will consist of certain quantity. Like if we talk about the size of ball, we might measure the size of ball into few centimeters. So the value can be 5 centimeter, 10 centimeter, 12 centimeter, whatever the measurement is. So in dimensional modeling, the very first thing that is important is a fact, which is itself a collection of associated data items. Data items which are associated in some way. It is a collection of that. And it will consist of the measures and the context data. So, facts, they are used to represent the business items or we can say the business transactions. The second element of our dimensional modeling is dimension. Dimension, it is a collection of data which describe one business dimension. Basically, dimension, it will decide the contextual background for the fact and they are the framework over which our online analytical processing it is performed. So like we have seen, if we talk about sale of a particular factory in which various products are produced, so the dimension according to which we want to view our data, it can be on the basis of timing, like we want to see the time dimension, quarter 1, quarter 2, quarter 3, quarter 4. So that is a kind of time dimension. We might want to see the location of it. So location is the second dimension according to which we can view our data. So location can be like Mumbai, Bangalore, Calcutta, Delhi, any location. Similarly, we can have another dimension like we can have the price. So what is the price of the item? So depending on that, that can be one dimension. So basically dimension, it is a collection of data which will describe any one business dimension. They basically decide the contextual background for the fact. Like if you see the area Kolkata. So Kolkata, it belongs to the dimension of location. So that is the dimension for it. Our fact there is Kolkata and the dimension for that is the location, that it is representing a particular location. Thirdly, we have the measure. Measure, as the word says, numeric attribute of the fact, the numeric value, representing the performance or the behavior of business relative to that dimension. The numeric value, like if we say the number of items sold, like we have bread, we have milk, we have jam. So the measure would be 350. That means 350 items are being sold. So that exact measure, that numeric attribute of the fact, that will represent the measure for it. So these are the three basic elements of our dimensional modeling whenever we want to see our data in the form of dimension from a different perspective. So in that case, we can use dimensional modeling. And these are the three important terms: fact, dimension and measure. This you should understand if you are referring to the measure. If somebody says find out the measure of milk, so you should be knowing that now in dimensional modeling there we are talking about the numeric attribute of that particular item. So if somebody is saying dimension, show me according to the dimension of location. So that means you have to know that you are focusing on the location at that point of time. Fact means the collection of the associated data items. So these are the three important elements of our dimensional modeling. Now, fact table. This is one thing. A fact table is a table in which all the facts are kept. They have a number of rows. Like there are certain values related to the fact. So they have a large number of rows. So facts, they are used to data the facts or measures in the business. So fact table is a particular table which is designed to keep the facts or the measures for a particular business. Facts, these are the numeric data elements that are of interest to the company. So fact is what? Fact table is what? It is used to data the facts. If you want to keep all the facts, that what are the facts related to our business. So for that we would require a fact table. Now we are talking about the characteristics, that what are the main characteristics of our fact table that we have designed. The fact table, it will include the numerical value of what we measure. For example, a fact value of 20. If somebody says the fact value is 20, it means that 20 widgets have been sold. So what is this 20 representing? 20 particular item. So that is what we have to store in our fact table. Each fact table, it will include the keys to the associated dimension table. Every fact table has to include the key. That means key is what? Key is some particular thing that will associate it with another thing. Let us understand that what a key is. Like if you are studying in your particular course, like you are studying MBA, so you have been, if somebody wants to recognize you, so the key that has been associated to you is your roll number or maybe the admission number. So that is the key, that if somebody says roll number 1, so that is your primary key. That is a key using which we can refer you. Similarly, admission number is one key using which you can be referred. So key is something which is used for referring. So every fact table, it should include the key to the associated dimension table, that to which dimension table does this fact table belong. These are the known as the foreign keys in the fact table because they are taken from some other place. So that is why we call them the foreign keys. Fact table, they typically include a small number of columns. When it is compared to the dimension table, fact table, they have a large number of rows. We are going to be talking about dimension table and as well after this. So fact table, you should understand the difference between the dimension table and the fact table is, fact table, they have a large number of rows because we have many values in it. So they have large number of rows when we talk about the fact table. Now talking about the dimension table. Why do we use the dimension table? Dimension table, it establishes the context to the fact. That means this fact, it belongs to which dimension? That will be represented in the dimension table. Dimensional table, they store the fields that will describe the fact. Talking about few of the characteristics of the dimension table. First of all, dimension table, they contain the details about the fact. Like as an example, it enables the business analyst to understand the data and their reports better. If we have certain dimension table related to our fact, we will exactly get to know that what does this represent. This fact represents what. So it will enable our business analyst to analyze, to understand the data better, so that they can create better reports for themselves related to those facts. The dimension table, it will include the descriptive data about the numerical value. If we have certain numerical value, dimension table, it will represent that a description related to it. It will include the descriptive data about our numerical value that we have in the fact table. That is, we can say they contain the attributes of the facts. For example, the dimension table for a marketing analysis. If we are talking about a marketing analysis function, what can be the elements of dimension table? It might include the attributes like time, like the marketing region or the product type. So these are the various dimensions according to which we can view our data. If we are understanding the dimension table for a marketing analysis, so for marketing analysis, like it can be, we want to see the sale at a particular quarter, that in this quarter how much of our products have been sold. So time is one dimension for us. Then marketing region, to which region does it belong, that is another dimension. And product type, that means what was the product type that we have sold. So this all we have to store into our dimension table. Since a record in a dimension table, it is demodularized. It usually has a large number of columns. Like we talked about the fact table. In fact table, we have more number of rows. But in dimension table, we have different columns, more number of columns. The dimension table, it will include significantly fewer rows for observation. For the information, it will store less number of rows, but it will have more number of columns representing each dimension. So the various attributes in our dimension table, they can be represented using certain column heading. With some column heading, we can represent our dimension in any particular document, or maybe for the purpose of query analysis or for any reason. So dimension table, they will establish the context of the fact. So these two, fact and dimension, they are interrelated. Fact is representing the exact value and dimension will represent the reference to that what is this value representing. So the fact table, it will have the number of rows in which all the values will be there. In the dimension table, we have the column headings. Like what are columns, what are dimension we can view our data from. So these two are important concept of our dimensional modeling. Talking about another important concept here, that is the surrogate key. Like I've told you about primary key. Primary key is your key using which you can be represented. Like your name. Name cannot be used as a primary key. With name, if we say somebody has a name like Rahul, so there can be some other student also who can have the same name. So if somebody refers to you as Rahul, so you do not exactly know which Rahul it is being referred to here. So our Rahul, our name, it cannot be used as a primary key. Primary key is something that has to be unique to you, like your roll number or your admission number, that is unique to you. Now coming to the surrogate key. Surrogate key, they are also called as a synthetic primary key. It is generated when a new record is inserted into a table automatically by a database, which can be declared as a primary key of that table. Like we have a particular table and we do not have any particular primary key for that. So synthetic key, or we can say surrogate key, these are the same terms, surrogate key or the synthetic primary key. It will be generated when a new record is inserted into a table. When a new record is inserted, so that can be automatically updated by the database and it can be declared as a primary key of the table. So a new record which is inserted it can be called as a synthetic primary key. It is a sequential number outside of the database that is made available to the user and the application, or it acts as an object that is present in the database, but it is not visible to the user or the application. This surrogate key, it will be present into our database, but it will not be visible to the user or the application. So we can say that in case we do not have any natural primary key in the table, then we need to artificially create one in order to uniquely identify a row in the table. We do not have any primary key in our table, but our records, they have to be referred to with certain number. So this surrogate key, it is artificially created by the database. So whenever a new record is inserted, now whenever any record has to be referred, it can be referred using the surrogate key. Because surrogate key, it will uniquely identify a row in a table. But this particular surrogate key, it will not be visible to the user or to the application. It will only be used by our database for referring to the data. However, surrogate key, it is not always a primary key. Like we have multiple objects in a database which are connected to the surrogate key. Then we will have many to one association between the primary key and the surrogate key. And the surrogate key, it cannot be used as a primary key. It is not so that surrogate key, it is always used as a primary key. There can be many a times when we have multiple objects in a database which are connected to the surrogate key and which will have many to one association between the primary key and the surrogate key. And the surrogate key there, it cannot be used as a primary key. Talking about some of the features of surrogate key. First, it is automatically generated by the system. You do not have to define that particular key. Whenever a new record is inserted, now our database has to refer to those records, so it will automatically generate that particular key. Then, second point, it holds anonymous integer value. It can hold any particular value, any anonymous value. Next, it contains a unique value for our data because it has to be used for referring to the various contents. So it can be used as a unique value for them. This surrogate key, it contains a unique value which can be used for referring to the records. Next feature of our surrogate key is this value that the surrogate key has. It can never be modified by our user or our application. Because at the end of the day, this particular value, it is going to be used by the database to refer to the records. It is in a way serving as a primary key. Though it is synthetic, it is just created for the usage of database, but it should never be changed by the user or the application. Like if we are talking about your roll number, you yourself as a user, you cannot change your roll number. That is being associated to you from your teacher or from the admin part or from some person. So here our surrogate key, it is also being used as a synthetic primary key. So it can never be changed or modified by the user or the application. In a way, surrogate key, we can call it as a factless key also because it is used just for our ease of identification of the unique values. And it is just going to be used by our database to refer to the records. So we can call our surrogate key as a factless key because it actually does not hold any proper information. It is just being used to refer to the records. So that is the concept of surrogate key. So it is generated when a new record is inserted into a table automatically by a database, and it can be declared as a primary key of that table. If our table, it is not having any primary key, so when a new record is inserted, a database creates its own surrogate key to refer to the contents of that table. to refer to various records in the table. So that is what is our surrogate key. Now, talking about alternative table structures, star schema design, and many related concepts. They are highly relevant to developing the power business intelligence model, which are optimized for performance and the usability. So whenever we have to design our business intelligence model, we have to use a particular design for it. We have to use a particular schema for this, that in what way should we design this particular model. So our star schema design and various concepts which are related to it, which are highly relevant to when it comes to developing the business intelligence model. Consider that each Power Business Intelligence Report visual, it generates a query that is sent to the Power Business Intelligence model, which the Power Business Intelligence service calls a dataset. Now these queries, they are used to filter, they are used to group, and they are used to summarize the model data. So here, a well-designed model, then it is one which provides the tables for filtering and grouping. So we require certain table structure also, because whenever we need to raise a query, so suppose we are talking about a factory which produces various products, we want to see the products sold in Q1. So it will require certain filtering of data. It will require us to summarize the data. Like we just want to see that particular data, summarize data. So for that we would require some table. So if we have a well-designed model for our business intelligence system, so it is one which should provide the tables for grouping, for filtering, and for summarizing our data. This design, it fits well with the star schema principles. Like if we are talking about our basic principle, basic way in which we design our business intelligence model, that is a star schema. So this particular design where we want to have some alternative table structures, so that can be easily done in our star schema design. This design, it fits well with star schema principle, like dimension table. They support our filtering and grouping of our data. Whenever we do not require the whole set of data, we can filter data. So our dimension tables that we have here, it will support the filtering. And if you want to group certain data together, so then also our dimension table can be used. Then we have the fact tables. Fact tables, they will support the summarization. If we do not want to see all the records, we want a summary of that. So our fact table, it will support the summarization. So dimension table, it supports the filtering and grouping, and the fact table, it will support the summarization property. So there is no table property that modeler set to configure the table type as dimension or fact. So it can be determined by the model relationship itself. So here we do not have to use too many table structure. We can use the dimension table and the fact table, which can be used for making these kind of conditions, for filtering our data, for grouping our data, or for summarizing our data. And it is a cardinality property that will determine the table type. So that is why we use our star schema design, so which are basically used to power the business intelligence models. Now, talking about MOLAP, or we can call it multi-dimensional OLAP. OLAP is online analytical processing. Now, we are talking about multi-dimensional OLAP. So, MOLAP, it is a classical OLAP which facilitates data analysis by using multi-dimensional data cube. Like we have a data cube in which we have different sites. These sites, they can be used to store different dimensions of the data. One particular side of our cube, it can be used to store the location. Another side of our cube, it can be used to refer to different types of data that we have. Another side, it can be used to define the time dimension like Q1, Q2 and like that. So why we are using this multidimensional OLAP? Because it will facilitate the data analysis by using a multidimensional data cube. Our data, it is pre-computed, it is re-summarized and it is stored in our MOLAP. Earlier we used to have ROLAP. ROLAP is Relational Online Analytical Processing. In ROLAP, what used to happen? Whenever we have to store some data, it has to be stored in the form of a relation. Relation we call to a table here. Like whenever we want to store the data, we store it in the form of tables. Table we can call relation also. So in a particular table, we normally have only two sides. We have the columns and we have the rows. So only that particular dimension can be used there. But nowadays we want to view our data from different perspectives. So for doing this, we would require a MOLAP rather than ROLAP. So using a MOLAP, which is a multidimensional OLAP, a user can use multidimensional view data with different facts altogether. Multidimensional analysis, it is also possible if a relational database is used. But that would require querying the data from multiple tables, because one particular table, it can hold only two things, the rows and the columns. So when we have to refer to our data, we would require, whenever we need to raise a query, we would require connecting different tables together, connecting multiple tables together. So that will be again our task, to connect all these tables using certain keys, so that they can be referred to each other. So, and that is a time-taking task too. On the contrary, our MOLAP, it has all possible combination of data which are already stored in the multi-dimensional array. So MOLAP, it can access this data directly. Hence, MOLAP is faster compared to our ROLAP. Earlier, we used to use this relational online analytical processing. Like you can consider it, if you want to store certain record, you can use our MS Excel for creating the tables, but in that you can have only few rows and few columns. If you want to view the data from different angles, at one point you want to store the quarters, at another point you want to store the location, at another point you want to store the information about all the items. What would that require? That would require connecting all these tables together to gain a particular record of it. But in MOLAP, that does not happen. We already have all possible combination of data stored in the multi-dimensional array, so they can be easily referred. So that is why MOLAP, it is faster compared to our ROLAP. Talking about few of the advantages of our MOLAP technology, that is, we store our data in the form of multi-dimensional cube. So the very first advantage is excellent performance. A MOLAP cube, it is built for faster information retrieval, and it is optimal when we require certain slicing operation, we require certain dicing operation. So when we require these kind of operation where we want to see a particular point of data, a particular record, so at that point our OLAP, this MOLAP, it provides us excellent performance because it is built for fast information retrieval. Second, it can perform complex calculations. This is the second advantage for it. All the calculations, they have been pre-generated when the particular cube is created. So the complex calculation, they are not only possible, but they return quickly, because when we are designing that cube, all the calculation, they are pre-generated, so that whenever somebody requires that information, time should not get wasted in performing those calculations. They can be easily retrieved. So our second advantage for our MOLAP is it can perform complex calculation. So the two basic advantages are excellent performance it provides us. Second, it can perform complex calculation. But we have definitely some disadvantage of our using MOLAP technology also. The first advantage is limited in the amount of information it can handle. Because we have seen that all the calculation they have performed when the cube is built. So it is not possible to contain a large amount of data in the cube itself. That is not possible. So that is why it is limited in the amount of information it can handle. Second drawback is it requires additional investment. Cube technology, it is generally proprietary and does not already exist for the organization. So to adopt this MoLab technologies, some investments have to be made for that particular specific organization. Some human resources are required, some capital resources are required. So we need to make certain additional investment when we want to use this cube technology. That is the MoLab technology. So any organization, it would require more investment when it is going to use this MoLab technology. So these are few drawbacks of using our MoLab technology. And so here we complete with our unit 1 of our subject business intelligence. So by far we have understood through this unit that what is business intelligence exactly, what is the proper structure of our business intelligence. Then we have also studied about multi-dimensional analysis, that how can we perform the multi-dimensional analysis, or the related term we have studied. We have also studied about the dimensional modeling, the facts, the attributes, the measures, and these terms are also clear studying this unit.